Antarctica. At first glance, it appears barren and static, a vast white desert where almost nothing moves. Over 98% of this land is entombed under ice that averages over 2 kilometers thick, reaching nearly 5 kilometers at its deepest. Beneath that frozen shield lies an unseen world of valleys, peaks, and water. No human eye has directly beheld this secret domain, yet it teems with hidden lakes and flowing rivers trapped in perpetual darkness. In one subglacial lake, drilled a kilometer below the surface, scientists recently found hundreds of new microbial species thriving without sunlight. Even in the most extreme isolation on Earth, life finds a way. These discoveries hint at just how much of Antarctica's story remains untold beneath the ice. Still, modern science has begun to illuminate this darkness. With ice-penetrating radar and ingenious experiments, researchers are mapping Antarctica's under-ice landscape. They have revealed mountains taller than the Alps and lakes the size of large cities, all hidden under the ice. More astonishingly, they've discovered a network of rivers flowing beneath the glaciers, rivers that twist through the black under-ice caverns and even defy intuition by running uphill under the immense pressure of the ice above. These subglacial rivers connect the buried lakes into a vast, secret hydrological system. Antarctica, the coldest place on Earth, is not a static block of ice at all, but a dynamic continent with water coursing through its veins far below the surface. How did we discover this hidden world? For decades, scientists have flown aircraft back and forth over the ice, sending radar pulses deep into the sheet and listening for echoes. Bit by bit, these signals sketched out the shape of bedrock and water far below. The picture that emerged was breathtaking. Beneath the East Antarctic ice sheet, for example, lie entire mountain ranges and over several hundred liquid lakes. These lakes are kept unfrozen by heat from the Earth and the crushing pressure of the ice. Meltwater from the base of the ice sheet feeds them, pooling in basins and valley bottoms over millennia. And linking many of these buried lakes are narrow, sinuous rivers, water sliding through pitch-black tunnels in the ice. At first, those narrow subglacial rivers were hard to pinpoint. Radar can miss such thin strands of water. So scientists devised clever models, using the known topography under the ice and the laws of water flow to predict where rivers should run. They found that subglacial rivers often follow the lie of the land, but with a twist. Under the colossal weight of the ice, water doesn't behave like it does at the surface. It flows under pressure, seeking not just lower elevation, but also areas of thinner ice above. In essence, water under an ice sheet will sometimes climb uphill toward regions of less overlying weight. This means rivers can creep up and over ridges or climb the flanks of buried mountains, a phenomenon virtually unique to these secretive waterways. Using these methods, researchers mapped dozens of concealed rivers. They discovered that many of Antarctica's fast-moving glaciers, the ones sliding seaward most rapidly, have abundant water beneath them, acting as a lubricant. For instance, the unstable Thwaites and Pine Island glaciers in West Antarctica, one often dubbed the Doomsday Glacier, sit over geothermal hotspots and rift valleys that pump heat into the ice above. As a result, a steady supply of water courses underneath, greasing the ice's base and helping those glaciers surge more quickly toward the ocean. Scientists also noticed something curious around the edges of the continent. Fringing Antarctica's coast are vast floating ice shelves, extensions of the ice sheet that fan out over the sea. These shelves buttress the glaciers on land, slowing their flow. Satellites monitoring the ice shelves found unexpected hotspots of melting on their undersides, places where the ice was thinning far faster than surrounding areas. The seawater there is near freezing, so what could be causing such rapid melt? The mystery endured until researchers realized these hotspots occur exactly where subglacial rivers empty into the ocean. Pressurized fresh water from under the ice sheet was blasting out at the coastline like a fire hose, carving channels into the underside of the ice shelves. As that less dense fresh water shoots out and rises, it turbulently drags up warmer deep ocean water and slams it against the ice from below. One scientist described it as an upside-down waterfall, a roiling upwelling that can melt 100 to 300 feet of ice per year in focused spots. Suddenly, those melt anomalies made sense. The hidden rivers were not only there, they were transforming the ice above in real time. Each new discovery has added to an emerging realization. Antarctica's subglacial water network is crucial to how the whole ice sheet behaves. And as the climate warms, this network is changing in ways we are only beginning to grasp. Researchers predict that, as surface ice continues to thin in coming decades, these concealed rivers will swell and shift, even jumping their banks to carve new paths. In other words, the plumbing under the ice will rearrange itself. This could send more water gushing out at the coasts or under new parts of the ice sheet, with potentially dramatic consequences. Understanding this hidden system has become a scientific adventure at the edge of the world, and in this quest, humans have found some unlikely allies. Meet Antarctica's unexpected research assistants, the seals. In the midst of the polar winter, when the ocean freezes over and the polar night sets in, nearly all scientific ships and instruments must retreat, but the seals remain. Diving beneath the sea ice in search of fish and krill, these native divers can reach depths of 700 meters, over 2,200 feet, and roam far beneath the ice where humans cannot. Sensing an opportunity, researchers have spent the last decade enlisting these marine mammals to help explore Antarctica's hidden waters. They fit the seals, usually southern elephant seals or Weddell seals, with small temporary sensor packs glued to the fur on their heads. The devices, weighing only a few hundred grams, record depth, temperature, salinity, and other data every time the seal dives. When the seal surfaces for air, the instruments transmit the data via satellite back to scientists in near real time. These seal laboratories have revolutionized winter data collection. Even in the brutal dark of July, with minus 40 degrees Celsius temperatures and thick sea ice locking out ships, the tag seals faithfully gather observations from the ocean depths. They essentially carry oceanographic instruments into places that would otherwise be completely inaccessible for half the year. One international program, MEOP, Marine Mammals Exploring the Oceans Pole to Pole, has deployed hundreds of instrumented seals, yielding an enormous public database of polar ocean conditions. Each seal is like a little research submersible, except powered by curiosity and fish rather than batteries. The seals have helped humans make astounding discoveries. In 2024, a team studying the remote Bellingshausen Sea, one of the least explored Antarctic seas, combined data from seals and autonomous underwater gliders to map how meltwater from one ice shelf travels under the floating ice of another. The seal data revealed an underwater valley on the seafloor that no one knew existed. In fact, it was a submerged canyon guiding the flow of currents, much like how a river canyon guides water on land. The researchers aptly named it Seal Trough in honour of its finders. This hidden trough channels fresher melt-laden water along the coast, showing how one glacier's loss can affect others downstream. Half a continent away, in East Antarctica's Vincennes Bay, seal-equipped sensors led to another thrilling find. As several elephant seals wandered the bay's depths, their pressure readings suddenly indicated water far deeper than expected. The seals were diving into what should have been sea floor, meaning the sea floor was actually much lower than the old maps showed. Following the seals' lead, scientists later confirmed the existence of a gigantic undersea canyon over 7,000 feet, 1.3 miles, deep. It's as if the Grand Canyon had been hidden beneath the Antarctic waves. The team has proposed naming it the Mirunga Nuyina Canyon, after the elephant seal's scientific name, Mirunga, and the research icebreaker Nuyina that helped verify it. Through efforts like these, Antarctic seals have mapped uncharted ocean floors and traced secret pathways of water. Their data has shown warm currents sneaking under the ice, and even identified how fresh glacial meltwater spreads once it enters the sea. By wearing tiny high-tech hats, these wild animals are helping humans peer into one of Earth's final frontiers. It's a partnership of science and nature that not only advances knowledge, but also captures our imagination. A reminder that sometimes the best explorers don't carry compasses or PhDs. Why all this effort to understand water we cannot see? Because these hidden rivers and the ocean they feed into hold tremendous sway over the future. The Antarctic ice sheet is so massive that if it ever completely melted, global sea levels could rise about 60 meters, enough to drown entire cities. Even a smaller loss, like the possible collapse of West Antarctica's Thwaites Glacier, would raise seas by over 3 meters worldwide. The fate of this ice rests not only on the warmth of the air above, but also on the warmth and motion of water below. Subglacial rivers and ocean currents are the unseen engineers weakening the ice from underneath. By lubricating the base of glaciers, subglacial water can speed their march to the sea. And when those rivers disgorge under floating ice shelves, they can greatly accelerate melting by stirring up warm ocean water. Scientists now realize that the interplay of these hidden rivers may mean ice sheets can respond to warming far faster than we once anticipated. One recent study showed that if subglacial discharge is included in models, the projected ice loss from a major East Antarctic glacier known as Totten jumps by 30% by the year 2100, and that study assumed the rivers stayed as they are today, but they likely won't. As Antarctica warms and thins, those sub-ice channels are expected to widen and new ones will form, potentially increasing the flux of water outwards nearly 5-fold by century's end. In fact, by 2100, the river beneath Totten Glacier could be gushing out water at a rate about 1/4 of the flow of the mighty Colorado River. This torrent would drive ferocious upwelling and melt beneath the ice shelf, further hastening its demise. It's a chain reaction: more melting, more water, faster flow, a feedback loop hidden under the ice. Including these factors is essential for predicting sea level rise accurately. Until recently, many computer models of ice sheet behaviour didn't account for subglacial rivers or the complex under-ice landscape. Now, thanks to new data from radar mapping and seal-borne sensors, scientists are improving these models. The information from our seal partners is especially valuable in winter and in remote regions, filling in blanks on our maps and alerting us to pathways of warm water that could spell trouble. By knowing where deep troughs and channels lie on the seafloor, researchers can foresee where melting might intensify as the ocean infiltrates those spaces. In short, every piece of this puzzle, each hidden river's course, each canyon's depth, helps us better foresee how the ice above will behave in a warming climate. There is also an intrinsic wonder and responsibility in unveiling Antarctica's secrets. The hidden rivers beneath the ice remind us that Earth's last pristine continent is very much alive, its icy facade hiding a labyrinth of water and life. Understanding this secret world is not only about predicting disaster, it's about marveling at the planet's capacity for surprise and resilience. The data gathered may even guide the search for life on icy moons, or teach us how life endures in the darkest conditions. Finally, the alliance between scientists and seals highlights an inspiring truth. Innovation in science sometimes means thinking beyond the lab. Who could have imagined that wild seals, freely roaming under the ice, would become our informants on the climate's silent underwater drama? Yet here they are, fearless, flippered oceanographers helping to safeguard their own home. As the sun returns each spring to the far south, the surface of Antarctica remains as austere and tranquil as ever. But now we know, deep below those tranquil white plains, rivers are running, carving paths in secrecy and darkness. Water is whispering its secrets to anyone who knows how to listen, and with a little help from some whiskered colleagues, we are learning to listen. In the face of a changing climate, these hidden rivers and faithful seals carry a message for us all. There is more to Antarctica than meets the eye, and its unseen currents today will shape the world's oceans tomorrow. I hope you enjoyed our very first video here on Earth Lore. It would mean so much if you could like and subscribe. Keep an eye out for our next video, and hopefully we'll see you soon.